In this video, we will talk about the biodegradability of bioplastics. Nowadays, the effective of solid waste management is facing global challenges, especially plastic waste is one of the serious problems. And since 1970, the production speed is faster than any other material. According to UN Environment Program, the production of global plastic products will reach 1.1 billion tons in 2050. And after reusing these kinds of products, we only can dispose in the landfill. And the plastic products have caused serious consequences for the environment, social, economy, and health. But how about the bioplastic?
Since conventional plastic could bring convenience to the public while causing some environmental issue from waste management. But without these products, is there any replacement that can possess the same function as conventional plastic and is more sustainable? Bioplastic could be the most suitable choice. But what is bioplastic and why is it? Bioplastic is made from renewable biomass like sugarcane, potato, cassava, or vegetable oil. Compared to the conventional plastic, which is made from petroleum and natural gas, bioplastic is way more environmentally friendly. Due to its components, most of the bioplastic is biodegradable that would not occupy too much space in landfill. Also, it may produce less toxic and greenhouse gases during the manufacture and reserve more oil for any other use. As a result, bioplastic is a sustainable product that will drive the future of plastic.
Now I would like to describe the composting in bioplastics. Compostable bioplastics are defined by American Society for Testing and Materials as bioplastics which are eligible for biodegradation under composting environment to obtain CO2, water, inorganic compounds at a similar composting rate of other known compostable materials without any toxic residues. There are various factors which affect the composting rate, such as moisture, temperature, oxygen availability in the composting environment, and structure, molecular weight, size and shape of the bioplastic. And the preferable conditions are moderate moisture level, temperature of 55 degrees Celsius, sufficient oxygen, low crystallinity in the bioplastic structure, low molecular weight, and large surface area of the bioplastic. These are some examples of the composting rate of bioplastics in the available sources. They examine the compostability of cellulose-based bioplastic and polylactide, which are frequently used as food container material. In a 2 weeks to 6 weeks time, both the cellulose-based bioplastic and polylactide.
The following part will discuss about anaerobic digestion of bioplastics. Anaerobic degradation is a biological process that transforms organic matter in an oxygen-free environment. It can follow two routes. The first one is anaerobic fermentation, where organic matter can act as an electron donor and receptor at the same time. The second one is anaerobic respiration, which requires acceptors like carbon dioxide or sulfate. The process is developed in 4 stages. The first one is hydrolysis. In this stage, complex organic matter such as carbohydrates or protein is converted into soluble organic molecules like sugar or amino acid. The second stage is acidogenesis, and volatile fatty acid is formed. The third stage is acetogenesis, and in this stage, acetic acid, hydrogen gas, and carbon dioxide are produced. Finally, methanogenesis indicates the production of a mixture of methane and carbon dioxide, which also known as biogas. 2/3 of the methane is produced in anaerobic fermentation, while 1/3 of methane is produced in anaerobic respiration.
I will now talk talk about the comparison of the biodegradation process between conventional plastics and bioplastics under anaerobic conditions. First, conventional plastics, most of them are non-biodegradable, while for the bioplastics, it is obtained from renewable resources. It could be starch-based or PLA-based. As mentioned above, the anaerobic process of bioplastics to degrade will release methane and carbon dioxide. We can deduce their biodegradability by measuring the amount of biogas released. During the biodegradation process, temperature is the most significant factor affecting the results. From the figure, we can see that higher biodegradation rates for thermophilic than in mesophilic conditions. Moreover, bioplastic shows higher mineralizations than conventional ones. Bioplastics have a biodegradability of 98.9%, while conventional ones have 0% without the biocomposite. In conclusion, bioplastics have a much higher biodegradability than the conventional plastics under anaerobic digestions.
According to the able description, it pointed out that the bioplastic are good substitutes for traditional plastic. In nowadays, those of them has been integrated into people's daily lives, such as medical products, consumer electronic products, in packaging productions, and disposable products. But why do people choose to use bioplastic in their daily lives? That's because those of them bring us some benefits, as those products can be easy to recycle. Also, the production of bioplastics require less energy. Moreover, bioplastic products can convert into compost after decay. Finally, bioplastic products generate less greenhouse gases emissions than traditional plastic products. It can be seen that bioplastic has brought many benefits to the environment, as long as those products are slowly integrated into our daily life. Hope those changes in material used will bring a more sustainable living environment and create a better living environment for the next generations. Here are the references that have been used in this video. Hope you enjoy it. Thank you for watching.